Welcome to the HiRSE Seminar Series on Research Software Engineering in Helmholtz and beyond.
Okay, you should be able to see my... okay, thank you very much.
Great.
Okay, so as Claire was introducing, well, me and my colleague Samuel will introduce a little bit one of the developments that we have done in the context of the European Open Science Cloud, which is the SQAaaS as a service, which stands for Software Quality Assurance as a Service, and we usually know it as SQAaaS platform. So the idea here, as I will introduce in a few slides now, is that there are two main objectives, two main goals that our platform aims to contribute to. One is the bringing novel quality practices close to researchers, and the other one is acknowledge and certify achievements in terms of quality. So, as I was saying, this is in the context of the European Open Science Cloud. For those that you don't know, is one of the pillars of the implementation of open science in Europe. Okay, so on the one hand, with the first goal, we build a culture of quality, and on the other hand, we credit those that are following these good practices. And when we are referring to quality of what we refer to these three digital assets or digital objects, in particular the source code, the service that you can see it as web services, so following this microservice approach where you can deploy different microservices, and then you are able to check or validate them in different ways, as we will see. And also we implement here in our platform fairness of the data. So the outcomes of each goal, on the one hand, whenever we try to approach or give these quality practices close to researchers, the outcome is the pipelines or workflows that follow different methodologies like CI/CD, continuous integration, continuous delivery, and also agile methodologies. And in the case of the crediting, we use the outcome are digital badges that use the open badges specification that we will cover later on, but it's an extended way of adding some more information about the validation process. So we will use, it allows this specification to use rich metadata in order to describe all the assessment and quality assessment process. For each one of the goals, we have to develop a different module, and these two modules are the ones that we will try to show today. We will perform a very brief demo of each one because we don't have a lot of time today. So on the one hand, whenever we are talking about pipelines, the services or the module is the pipeline as a service, and the awarding and assessment module that I will introduce right away. Obviously, we need to define different standards that we will follow in order to quantify and qualify the quality of these digital assets that we see here. So for the source code and the service, we have came up with a definition of the different quality criteria that is required for validating or for a comprehensive assessment of the quality of each one of these digital objects. As you can see, there are a number of different criteria that we check. And in this box, you can see more or less how these documents or this definition of each criteria is composed. So you have like an identifier of each one of the quality criterion, and then inside each one you will have usually different criteria and sub-criteria. There are different multiple releases of this of these standards, of these documents that you can find in the DOI, through the DOI, but you can also refer to the code repositories where we maintain these documents. So in case that you want to contribute, which are, as we state here, open, available, and yeah, we also promote a lot the collaboration from external sources, let's say. So here you can see, also how we group these quality criteria depending on the source code management, testing, whether the presence of different documents and files are there in the code repository or not. We are talking here about only about source code. Okay, so this is an example. Then code release, build and publish, and then deployment. Also, we need, I need to highlight that we are following the RFC 2119 specifications. So we use this terminology of must, should, and may whenever we're talking about the criticality of each one of these criteria. Okay, so going directly to our platform, we offer a web interface where you can access these two modules that we are, or features that we will talk about and we will show in a few minutes. We will start by the second one, and then Samuel will take over and will present the pipeline as a service. So in terms of the quality assessment and awarding, why do we think that quality assessments are important? Well, they ease the adoption and sustainability of the given digital object, no matter if it's source code, a service, or data. And what do we give? I mean, what is the added value of this module, of this service? Is precisely the digital badges, because you can have, in a very simple way, a very comprehensive list of information of the different criteria that has been fulfilled by each one of the digital objects, so you can share it and verify it whenever you want through the open badges specification. So usually in these demonstrations, we perform different steps, but since we don't have much time for this part, only 20 minutes, so I will just go through how a usual assessment for the source code is, which is the most straightforward, as you will see. And for that, we will use, as the use case, the OS performance tool, which is a software project developed by KIT and within the context of Synergy, which is the project that gave birth, let's say, to this platform. So since KIT is the link to this seminar, we think that this is a good example for us. So if we head over to the SQAaaS platform, this is the landing page. So well, you can sign in with whatever identity provider you have. I already have signed in before, so that's why it doesn't prompt me for any credential. So very simple, you have the two modules available. I will go through the quality assessment as promised. Here you can see that in the different tabs, you can perform the validation of the different digital objects. And for the service and the third part, as you can see, you need to select the tool that you want to use in order to deploy the services for the platform subsequently, so the platform subsequently can validate it. And for the fair, you also need to select the tool. We offer two ones here, and then it's just a matter of adding the different information. In the case of the source code, that is the one that we will show now, it's just a matter of adding the repository URL. And in case that you are or you want to use a specific branch or tag, you can do it as well. This other field is external documentation repository. So in case that you are maintaining your documentation, the documentation that is related to the source code in a different repository, you also need to add this information, because we also check a different criteria for the documentation. So as promised, we will use the EOSPerf tool that you can see here. So it's just a matter of copying the URL, sorry, and we place it in the repository URL, and we can start the assessment process. It's as simple as that. Okay, so while we wait, because this takes some time, since it's composing the pipeline with all the different checks that will be performed, so it takes some time. Okay. In terms of the capabilities of the QA assessments, sorry, there are a few things that we could highlight. Only Git is supported for the time being. This is quite a major requirement, but in principle, since Git is widely adopted, this is not usually a problem. And there are no real plans to support additional version control systems. So in the end, we are quite focused on Git at the moment. Only public repositories can be assessed now. We are working right now in supporting private Git repositories. So we will use different technologies in order to be as secure as possible. Indeed, this new feature is on testing now in our staging environment. So it will be ready very soon. And then we have support for, some of the criteria that we have defined in those documents that I was mentioning before, usually are tied to a given programming language. So, for example, if we want to check the code style, we usually need to, obviously this is tied to a given programming language and a specific standard. Okay, so there's the need to have this specific support for each standard and each specific programming language for some of those criteria. For the time being, we have support for these programming languages that you can see here. But we are extending our support not only in terms of programming languages, but also in terms of tools. Anyway, if you find something or you want to you have one tool that is not supported right now and you find interesting, you can always drop us an email or fill in an issue in those repositories, and we will be glad to cover it. Summarizing a little bit, the tools that we are currently supporting for this specific criteria that needs this support is, you can see it here, Git for the code management, and there are different tools for the different programming languages for code style security and documentation. As a final one, apart from the final outcome, let's say, of the quality assessment that we started now is a quality report. And in case that a minimum set of criteria has been fulfilled, you will also get a badge. A very simple approach, just the gold, silver, and bronze approach. And here you can see in this table the mapping between the criteria and the badge. Okay, so the ones that are in green are the ones that we are still not supporting for the time being. But the rest, as we will see, are there. The same for services and data. Here you have the mapping between the quality criteria for services and the different badges, and also the images for these badges. And about the digital badges themselves, as I was saying before, we are following this open badges specification, which is powered by Mozilla. And the good thing, or the added value of this specification, when compared to other different badge technologies, let's say, is that we can provide additional metadata through the badge itself. And in particular, the evidence property contains the relevant info about this assessment process that we are performing, covering all the different criteria that has been evaluated and fulfilled. And another added value, let's say, is that these badges are shareable and verifiable. So you can always check, I mean, they are trustworthy badges whenever you get one. There's as we will see also in the report, as a result of the assessment, these badges can be easily shared. So the web interface provides a way to copy or generate the required markdown code that is needed to be pasted inside the README in your code repository. And we offer two approaches, either using our own image or the usual Shields.io type of badge. Okay. And well, I think that we can try to, yeah. Okay, so this has finished. We can see here the final report, the quality report, which is structured in two different sections, the badge report and the criteria report. As you can see, the EOS-PERF has obtained the silver badge. So you can, as we were saying before, you can verify it through the Open Badge validator, okay? Or you can go to the page where this additional metadata is displayed, in particular listing the different criteria that has been fulfilled, the commit ID of that has been evaluated, and also you have different evidence. In this case, for example, is the build that has been performed in our continuous integration system in Jenkins. So you can see how the assessment has been executed. So there are different criteria that has been checked. Some has finished successfully, and other different ones have not succeeded. And here we have all the different logs about how things were executed and in the building process. So this is quite an added value, let's say, because we have always this information available for this specific commit. And in case that this is a release, like a tag or something similar, you can always link this tag with the associated, let's say, badge or quality report. As I was saying, there are two different ways of sharing this. Always putting this code in your README, so it's just a matter of selecting the one you want, and this will copy to your clipboard, so you can copy paste it in your README. And then there is this table summarizing what criteria. Well, it's like a summary of the table that we have seen before, between this mapping between the criteria and the badge. So we can see here that for obtaining the gold badge, we failed to fulfill the code style and the security. And then in the criteria report, you have first a summary of each category of criteria that we are checking, and then a more granular, let's say, breakdown of the different sub-criteria belonging to each criteria and how things work. Okay, so whenever everything is okay, you will have this message about what this code is actually checking. In this case, this is a README file which is present, or a code of conduct, or a contributing file. Everything is present there. So So is stated as or highlighted as a success. But whenever something is not something is not fulfilled, sorry, like following a specific style for the Markdown markup language, you will have always a hint saying or providing more information about how you could deal and try to improve this. So the next iteration you can have this quality check as successful. Okay, so in this case we use this doc as code approach, and either you follow the standard suggested by Markdown lint or the one for restructured text lint in case that you are using either one of these markup languages. And you will be able to fulfill this one. As you can see, for example, the documentation is stated here as successful, but you can see that one of these sub-criteria have not been fulfilled. Well, the answer to this is that, as we were seeing before, not all the sub-criteria has the same criticality. So in this specific case, fulfilling a style or following a style for the documents, Markdown documents, is not really a mandatory, let's say, or a must. So that's why the end result is okay. Anyway, as you can see, in either way, whether you, whether the sub-criteria is successful or is a failure, you will have this more info button where different information is provided about the result, and you can also there's a link for the Jenkins continuous integration service, so you can check further details there. But in principle, I mean, all the information can be accessed through the quality report. Quite handy. And this is it from my part, from the quality assessment. I will hand over, leave the floor now to Samuel to fulfill or to cover the pipeline as a service module. So, Samuel, when you want, I will stop sharing.
Okay, thank you,
The floor
Pablo.
is yours.
Let me share the screen. Okay, so I hope you are seeing my screen now. Okay, so moving on to the pipeline as a service part. So as Pablo mentioned before, there are two components on this service, the one for the assessments and this one for managing your own pipelines. So the pipelines for your continuous integration or continuous delivery workflows. So if you want to create your own pipelines, you can do it using this feature. When using this feature, it is possible to create your own pipelines with your own requirements and tools and functionalities that are supported over this platform. So here I'm going to show you a demo. So it was expected to show you two demos, but since we are short in time, we will focus only on the first one, to create, test, and share and use the CI/CD pipelines with SQA as a service portal. So regarding our demo, we will also keep the EOS project from Git, and we will move on to a specific branch. So this is a release that haven't been worked over the SQA that Pablo mentioned before using the assessment. And so it is a kind of pristine release. And then we will select the tools. So two tools for two different criteria. So the criteria for the security using the bandit tool, and the criteria for style, the criterion for style using the flake tool for Python. And then I will show you all the steps how we can just configure this pipeline and create a pull request over GitHub. Let me share again. Other screen. So this is the project. So we will start from here, from the EOSC the release V0. That it is the base project with all the changes. And when we start over here, so we go and enter on the platform, the SQA model selection, and select the pipeline as a service. Here we give just a name for our pipeline. Let's call it, in this case, EOSC perf. So next step here, since we want to override a default behavior that is whenever a tool fails, the pipeline stops. Here we will override that and just keep it running until the end. So we will select. We first point, we don't need to use any external repositories. So that is marked as no, because we are using the repository that we will reference later. And here, regarding the environments, so we will customize our environment and add a specific variable. So that variable will be the JePL keep going enable, that will allow to just keep the pipeline running until the last stage. So next we move on to the next step, and on next step we will select the criterion. So first will be the security one. And after we select the security one, we move down and we select the tool. The tool for security check with Python, we will choose here Bandit. And we will select options for the tool. Here we will keep all the confidence level as high, so we don't keep everything being just like noisy. And also the severity level to high. About the source file, where is the code that we want to check? Going back, so all the code here is inside this directory, EOSC_perf, and so we'll configure that over here. And we don't need any custom service. Here, custom service is if we need to use our own container with the tools for example, for Bandit on this case. But since we want to use the provided containers, we'll mark this as no. And so in the end, we just click above here to add the tool, and then add the criterion. Now move for the second criterion. So we just work on the security one, and now we will move to the style. On style, we again choose a tool. The idea was to use Flake8 for code styling of Python. Here we also select the same path for the project files that we want to check. That was EOSC_perf. And we don't want to exclude any files any files inside that directory. So we just add tool here, and again add criterion in the end. So what we get on this, we get the security criterion and the style criteria. criterion and at this order. So the pipeline will first run the tools related to the security part, and the second stage will run the style check tool. And then we click next. And you get into the page where we can create the pull request. So first of all, we can download the files if we only want to just get the code, the required code. So clicking here will download a zip with the files that you can just check and also add locally, for example, for your repository or to start testing things. But we also provide additional features. So you can also check the configuration that we did. You can also pull request, that is what we will do on this case, directly to GitHub. And we only, just like Pablo mentioned, we only support now GitHub. And you can also try out to execute the composed pipeline and check results directly over our continuous integration system. So this is the pipeline that will be created, and we'll just do a pull request to a repository. So the repository here is the one that we select in the beginning. So I will just copy paste the URL from the repository. This one. And the branch that we want to use as the reference. So release version 0. And then we click on pull. This will just create a new branch inside HiRSE perf using this code as base, and then applying the required files for to create the pipeline. So as it is now running, this is normally fast. So yeah, so it just creates the pull request, okay? And now we can check the pull request itself. So the pull request has been created here. So this second one, sorry, this first one, I mean, the 238. So it just creates this pipeline. And this pipeline is now running. So it automatically triggers the pipeline over our continuous integration platform, Jenkins, since we have already configured the integration over the HiRSE Synergy organization. That's why this is being running automatically here. So this will take some time, just like before Pablo. So this will run the tools, and we can also see what is happening here. So it's still running here. So you can see that the pipeline is running. And if we enter on the pull request associated with the pipeline, we can actually see what is happening. So actually, it is almost finished. So it already passed over the 2 criteria here, and it is now finishing, just cleaning up the workspace. So actually, this will be faster. Okay, so it's just finished, and we can check the logs for each criteria that we run. And we can actually see what have failed in the report of the tool. So you can see what happened, what is the issues that we add in the code, and take measures about it. The same thing for the style check. We can also check what is the issues here and just start doing the corrections. So this is a kind of not so fancy way, but it's also possible. For example, if you want to develop things before you do your assessment, since the assessment also uses the same tools, the default tools here. So you can actually test your own pipelines and check everything before, for example, you start running an assessment. Then it is also important to mention that you have access to all the code, like just Pablo mentioned before. So if you look into the pull request files changes, you can see what just result after our form filling before. So fulfilling before, just you can see here the tool, the parameters that are being passed to the tools, the container that were created, and also the details about the services that were started for these tests. And also this is kind of template file, the Jenkins file as one of the files. So there are actually 3 files that composes the SQA pipeline. It is the config file, the config YAML file, the Docker compose file, and the Jenkins file. Let me just stop this. Okay. So moving back to our slide from where we start. Sorry, the delay, just trying to keep things cleaner. Sorry. Okay, so this is the slide where we were before. So actually, we just did all these steps. So we create the pipeline for the security criterion with the bandit tool, the style criteria with the fake8 tool. We get the result of the pipeline using the web interface, and we watch the results and the PRs being automatically validated during all this run. So in sum, using the pipeline as a service, it provides a more fast and easy way to start off with CI/CD. So you don't need to understand the details about the configuration files and all these things. That was the point for the demo too. The graphical composition of the pipelines is one of the important features here, that you just start just going step by step and filling the forms, and you get your pipeline quick and easy. And you can also validate all your work before pushing the code to the main branch. Okay, so this can be also a tool for any developer start working with and get quick results. Also, this also allows you to use your own tools and have your own containers and get your pipelines working. Okay, and well, the only thing that the SQA platform doesn't provide is an integrated Jenkins. So if you want to use this SQA platform, you also need to have a Jenkins engine to run the pipelines. Okay, so the deployment here is about having the web service, the API on the SQA side, and additionally the Jenkins pipeline engine. Okay. Then there is a library that it is underneath all of these. That is the JePL library. It was a point for the second demo, but since we are out of time now, it is not possible to present you that details, but is the thing that allows to create the dynamic pipelines that is in the underground and created all this magic, let's say, like this. There is actually another kind of tools that can also manage this kind of pipelines. The difference here is that we always have an open code that can be managed by the community and can have all the, let's say, the features that are required by the community. So this is, I think this is one of the main points of the JePL library. So it is open and everyone can contribute to it, open software, so open source. And this is an important detail. And that's it. So thank you for your attention. Sorry that I think we just passed a few minutes after the scheduled time. And we are open for your questions. Me and Pablo, thank you very much.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below and see you next time.